So today, like Mark said, I'm talking about the Pennsylvania Underground Mine Mapping Project. Basically, I'm just going to show that we're working towards trying to make the mine mapping information available to the public and the industry as readily available as possible with less contact with us, which I know, sure you all would like a lot less contact with us. So I also had to delete some slides out just due to time. So the first couple slides don't really flow with the rest of the presentation, but once we get rolling, it'll be okay. I left them in because I wanted to talk just so you had an idea of some of the maps that we're dealing with. A lot of these abandoned maps are very old, early 1900s. Some go back to the mid 1800s. Back then, how they made these maps were they hand drew the workings on very large sheets of canvas, and then to make copies of those maps, they traced the workings off of linen. After the mines closed, a lot of them went bankrupt or just closed down. They didn't have a use for the maps anymore, and they stored them in some of the worst conditions for a mine map. They were rolled up, folded, put in boxes. Just some areas, they got a lot of water damage. They got lost when companies would move. And in some cases, unfortunately, they got thrown away. Why that's really bad is because that map might have been the only record of that mine. Why this is important, we want all the mine workings. We want to know where all the underground mines are, especially the abandoned mines. The active mining, I'm not really going to talk about active mining today because now there's a lot of things in place to keep that information really up to date. The newer maps are obviously a lot nicer using computers. So I'm going to kind of just focus on these abandoned maps. And the Mine Subsidence Insurance Program, that's the program that I work for. If you want to get mine subsidence insurance on your residential structure or commercial structure, if the mine collapses underground, it damages your house, we offer insurance to pay for that. Well, we need to know if the house or the structure is undermined, and we need these mine maps to know that. Mine safety is probably the most important. You guys probably remember the Q Creek. I mean, that was some years ago now, but basically what happened there was they were actively mining, and they had a mine map of an adjacent mine, and the mine map that they had showed that the workings were further away than they actually were. They punched through. These old mines are flooded, they're full of water, and that's what happened there. Mine reclamation projects, sinkholes open up to fill in sinkholes or could be worse. They need to know the workings, the extent of the workings to be able to do those projects. Oil and gas drilling, like Mark mentioned, I talk to him pretty regularly, just look up a site to know how deep the mine is for drilling projects or whether it's in an active permit boundary. And make government more efficient, which we all want. A lot of these lookups now, like back when you would call me, if this was even 5 years ago, it might take a week or 2 weeks to look it up because we actually had to take a topo map, find the site, go pull the actual paper maps, locate the site on those. With GIS and being able to Geo Reference the images, I can do it minutes. I don't call you back that fast. I shouldn't have told you that.
I have to wait a while.
So the DEP, we came up with a mine map plan, and the number one thing we want to locate is many sources of mine maps that are out there. So if any of you know of any collections, let us know. Would like to contact those people and see if we don't have the collection, if we could get it scanned. We want to then create a digital archive of the map, which I'll talk about in a little bit. Create a centralized database somewhere where no matter what office or the public or the industry can access the same database, get the information off of each sheet, or about each mine, and provide you guys access to it without going through us. But we're still here. You can contact me or us. So we started looking around, and DEP offices, there were ton. I mean, I have numbers coming up here. I think 60,000 paper maps. A lot of universities had collections. Indiana University, IUP, they had their own collection. Cambria County Courthouse contacted us. They were moving some maps, and they said, we have a whole collection of maps here. Do you want them? A lot of those maps we didn't have records of. And then private collections come in all the time. You would not believe how many people say, you know, my grandfather was a coal miner, and we were moving out their house, and we found a box of maps in the attic. We were going to throw them away. Do you want them? And again, that map might have been the only record of that mine. Yeah, so DEP, we have approximately 60,000 paper maps. Most of them are scanned, but not to our standards. So we're in the process of getting those rescanned. We have about 20,000 scanned. DC, and then outside collections, DCNR, which is state, but it's not DEP, they have approximately 15,000. And a lot of these maps are rolled up. A lot of times we think we have 500 maps, and when you're done with it, there were 2,000 maps in the collection. And we're constantly finding new collections. So once we get a collection, the first thing we have to do is scan the map. So we want to create an archive quality image. So 400 DPI, 24-bit true color, maps that basically you can't use on your computer because they're so big to try to use them in GIS. The reason for this is if something ever happens to those maps, you know, God forbid there's a fire or something like that, and you lose the maps, we can print that map and not lose any detail. But like I said, the problem with that is it leaves you with really large images. We have some maps over 2 gigs. These are just type scanners we use. Most of them we can run through a 56-inch roll scanner, but if you see on the map on the bottom there, that's one of those hardbacks that are the canvas backs. We call them hardbacks that I talked about. You see the colors. I mean, they were hand-drawn as they went through the mine. And we have access to 2 cruise scanners. They're very large flatbeds. IUP and Office of Surface Mining have them. And basically, the camera moves above the map, so it doesn't damage the map. Most of these maps are in really poor condition, and we also have Pitt University. University of Pittsburgh. They're restoring these maps, and it's a unbelievable process. It's amazing how much time goes into restoring one map, but they do a great job, and it allows us to be able to scan these. Acronyms, we were talking about them earlier. There you go, Fumus, Pennsylvania Historic Underground Mine Map Inventory System. My old boss is here. He put a lot into that, and here it is, Joe. It finally came to. What this is that database that everyone can access, and you can get information of all the mines. And it's a sheet by sheet, so you can see the date of that sheet, what the coal seam was, lots and lots of information. There's a screenshot of just searching it. It's pretty busy because there's a lot of features on the mine maps. You can search by location if you just want a township. If you know the mine name, there's just endless things you can search to bring up the list of maps. So we scan the map, we collect all the data in the database, and now we need to process those images. I mentioned how big the images are. You can't really use those in a GIS. So first thing we'll do is, if we had to scan multiple scenes, we'll put those back together using Photoshop, stitching it back together if we can. And then we convert it into, it's software through LizardTech. It turns it into a Mr. SID file or a SID file. And it's a 20-to-1 compression, and it is amazing. You don't really lose any detail, and the size of the images, you can, home computers run right through them, no problem. So then after we make the SID image, now we're ready to georeference it. So what we do, we bring it in, and we want to get at least 4 control points. Sometimes you can't do that, but at least 4. And we use, ideally, coordinates on the mine map. You could just, here's the coordinates, here's the punch it right in and be done. That never happens. I don't think I've ever seen it once in 8 years. So, and if you do, you don't know what coordinate system they drew the map in. So if it was 1910, so we use road intersections, structures, property lines, stream crossings, bridges. I mean, really anything we can. And we georeference them to, again, coordinate points. They're not realistic. So first we try to georeference to an aerial image for most accurate, and then we work our way down USGS topo map, parcel shape files. The historic topo map, sometimes that's all you have. I mean, the roads change, the railroads move, and that's all you have. They're not the most accurate, but it's better than not having anything. And then sometimes you can use the mine map, a georeference sheet right next to it. Limitations, unknown coordinate systems, lack of control points. A lot of times the draftsmen, they didn't really care what was on the surface. They were mining the coal, and they didn't draw the roads or structures. The original draftsmen, these guys were really good at. I mean, you look at these maps from how old they are and how accurate they are. They're pretty amazing doing it by hand. But surface control points move, or buildings get torn down or rebuilt. And then image distortions, like I said, these maps get damaged, stored poorly, get torn, and this one isn't as bad, but this is you see the intersection here. I don't know if you can see it. There's an intersection here. This is just a straight line. This kind of curve. The other one on the aerial curves a little bit. And the paper was torn here, which, depending on the scale of the map, that could be a 20-foot error, which for most of our instances, that's okay. I mean, we can have a little bit of error because the mine workings are right there. And we tell people, don't use our georeference images for engineering. It's in the disclaimers, really, because we're doing it the best we can, but it's a visual. It's not, you're twisting a sheet drawn in a different coordinate system. There's going to be some error. Newer maps, like I said, the active maps, they're a lot better. I mean, they match right up because they're drawn right now, real time, or close enough to what the aerials or the topos you're using. The field survey before a project. The Clyde Mine, this is a project I was just working on with in our office. Basically what happened was we needed to drill into a mine void to pump sludge. I don't want to get into the details, but drilling a hole is pretty expensive. I'm sure the gas industry, you guys, you know how much it is. And so I georeferenced the sheet as best I could a couple times. I went out and took GPS points, but we don't have survey grade GPS points, but I took some control points, checked it up, and came to a point where I felt comfortable about that it was as good as I could get it for them to drill in. So we got the coordinates, but before we drilled, we had a survey equipment, survey grade GPS unit brought in and used and redid the project, and I was off 12 feet. And I went with the survey grade equipment, and it hit the mine void on the first drill. If I wouldn't have done that, there's a good chance I would have missed. I would have hit solid coal, and we would have had to move the rig over 12 feet and drill again and hope it hits. And like I said, that's not cheap. And so if you're going to use our maps for something like that, please get some field survey of the site. We have about 9,000 maps georeferenced to date, so that's a good clip. But when you see 60,000 of our own, that's not that many. After we georeference the sheet, we also want to capture shape files or features off of the sheets. Active underground permit boundaries is a really big one for the oil and gas industry. That's what I get the most phone calls for. Am I in an active mine? If so, what mine? And I guess you have to contact you have to contact the mining company. Longwall panels, mine out areas. I have some screenshots of these. We do heads up digitizing, so when we georeference the sheet, then we basically just trace the workings, and there's a mined out area shapefile available. This is the active permit boundaries. The orange is the active boundary, the hatching is what the mining company submitted to add this onto their mine. It's just, it hasn't been approved yet. Longwall panels, the footprint. Gray's been mined out, red's active, and the purple here is projected. And if you look up here, it looks like there's no mining here because there's no longwall panels here. But if you add the mined out areas, you see the developmental workings here. So the mined out areas, has a lot more mine extents. And then we have an index map, or an index shapefile now, where every map we georeference, we index the 4 corners of the map, so you can look up your site and quickly know which sheet to look at. And then cool elevations, this isn't available yet. This is like a long-term project where the idea is to get enough cool elevations that we can create some layers and things like that, so we can quickly find out how much covers between the mine and the surface. Now, because there's only 6 of us in my office that do this, and use 60,000 maps, we'll all be long gone before anything, we knock that out. So we've gotten a grant, the Mine Map grant project. This is a huge project. This is going to help us tremendously. A bunch of universities and nonprofits got involved with the first round here, and they're going to do the same work. They're going to scan, georeference, inventory, the whole thing, and it started already, and we're going to be able to get those numbers increased greatly, and then that means we'll get them out to everybody else a lot faster. Public access, you can contact our office, and we can give you a cool status report. That's what we usually do. That's what I always would do for Mark. And basically, you just get a sheet, and it's just a 1-sheet report, and it has the mine name, the operator, how deep it is, which is the main thing, year it was mined, roughly. And so we have that, and then sometimes we can provide just a little 8.5 by 11 sheet to show you the mining under your site. Another acronym, Pennsylvania Spatial Data Access, PASDA. Don't worry about the website, just Google PASDA. It's the first one that comes up. And basically what this is where Penn State is basically running the site, and it's where you can download all this information. There's an online viewer, which I have a few slides I'll show you. So on PASDA, all the shapefiles I showed you, except for the cool elevations, are available. Mined out areas, the panels, and the active permit boundaries, and we update those pretty regularly in the Underground Mine Map Index. If you go to the PASDA homepage, it's kind of busy because there's a lot of data on there, but there is a quick link for PADEP, and it has all our information. So as of now, 16,000 archived TIFF images are available for download on PASDA. Almost 5,500 of them have been georeferenced that you can download, and the difference is the ungeoreferenced SIDs are available too, so you can download them and georeference them yourself. There is an FTP site as well, and there's a link on the PASDA homepage to the FTP that you can go. And DEP California is where most of these are now, because that's our office. So you'll go into there and it drills down. Okay, if you download a georeference image off PASDA, it's put together in a packet. It has the metadata, but it also has 3 different information files, so you can use it in Esri products, AutoCAD, or if anybody uses Map Server, the world file's in there as well, so it should read it in all 3. Okay, and this is the viewer. This is like the biggest thing for us that this case finally we've been able to launch it. If you go to PASDA and you click on the Pennsylvania Mine Map Atlas, this is what comes up. The pink, if you go in, it's a grid. It's that map index. It'll show you where there's mine maps that are georeferenced. And I think I have it here. Yeah. So you can search by an address or latitude, longitude. You just put them in over here and hit zoom to the address or zoom to the lat long. It takes you right to the point. If it's within one of these, you don't even have to see these. You just click, and it'll bring up a list. And Here's where you download the images. You highlight it if there's multiple images. It only shows one at a time. We couldn't get it to at this time yet. We can't get it to show 2 maps at once. So you can highlight to make sure you're highlighting the one you want to see. If you view it, you can zoom to it, and then if you hit View Map, it'll bring up the map, and you can adjust the transparency and see. Here's our office. Oh, I can't even. Yeah, we call it the chicken coop because it looks like a chicken coop right here, and you can see these are the mine workings under the office. And then you can also measure areas or distances, and you can also just print like a quick little map there, PDF, JPEG, whatever, just for your records.